I'm Chelsea Shammy Calder, and I am your session host today. Up next, we'll be joined by Michelle Hager of SAS, and she's going to present on accelerating data discovery in SAS Health with natural language queries using SAS via Copilot. So everyone join me in welcoming her to the stage.
Thank you, everyone. I'm really excited here today to come talk to you about accelerating data discovery in SAS Health with natural language queries using SAS via Copilot. So it has been documented that hospitals produce, on average, about 50 petabytes of data each year, or 137 terabytes per day. To put that in perspective, that's like saying if 1 million people took and uploaded 45 photos per day at 3 megabytes per photo. Or to put it another way, double the amount of data which is in the Library of Congress. To give you some perspective on petabytes, 50 petabytes is about 16.6 trillion photos, or a year's worth of daily photos from everybody on Earth, just 8 billion people, if they took 5 to 6 photos per day. That is a ton of data, and as technology continues to grow and advance, so does the quantity of data, whether that's through wearables or medical devices, genetic testing, patient-generated data, or just electronic health systems. So here at SAS, we have developed SAS Health featuring SAS via Copilot for clinical data discovery. Before I jump into Copilot, I want to spend a few minutes on a quick overview of SAS Health. SAS Health is an interoperability-driven data management and AI platform that can be used to support healthcare analytic use cases and drive business value across the care continuum. It is an end-to-end enterprise solution for health data integration, data management, and analytics built on top of VIA 4. We're really trying to drive value by addressing common interoperability problems that a lot of health systems have by creating a platform that consolidates data under one faster and more productive AI and analytic platform. I think probably are saying, well, great, that's great, but what exactly does that mean? We created a relational database with over 35 tables and 3,500 columns by taking the FHIR resources and flattening them so that the data could be more easily ingested. By doing so, we created a standardized common data model or unified common data model that can be housed in SingleStore, Snowflake, or Postgres. We populate this common data model using REST APIs to connect to sources such as Azure FHIR, AWS FHIR, Azure Blob, and AWS S3. Our no-code, low-code process eliminates the need to write custom code for data ingestion while still offering the flexibility for our customers to modify mapping rules or create data views easily through our user interface. As a result, our common data model and our ETL allows customers to easily enable analytics, reporting, and modeling to help provide insights and improve outcomes. Overall, this agnostic architecture gives us the flexibility and allows us to scale easily as technologies continue to adapt and grow. So while we were building SAS Health and our common data model and our ETL process, we started thinking and seeing some common themes come up. One of those was, why are teams still struggling with access to data? I'm sure a lot of you in the healthcare industry are not only familiar with the volume problem, but also familiar with this. So in healthcare, for those that don't know, data is really fragmented across multiple different systems, and they're usually disconnected, whether it's EHRs, claims, financial systems, or quality performance tools. This fragmentation makes it difficult for teams to access a unified view of the patient, data, cost data, and operational performance. As a result, healthcare teams are overwhelmed with frequent and ad hoc data requests, often scrambling to respond without the ability to easily pull together comprehensive analytical insights from multiple sources. Self-service data access is still quite limited in many healthcare organizations, requiring reliance on analytics or technical teams to pull together and generate reports. This dependency creates bottlenecks, slowing down decision-making and leaving non-technical teams struggling to get the insights they need when they need them. Additionally, translating complex healthcare data into a clear, understandable insights for internal teams or executives or external stakeholders still remains a significant challenge. Another barrier is the lack of SQL or business intelligence skills among healthcare professionals, making it difficult to run ad hoc queries or navigate complex analytical tools. This shortage of skills, combined with the limited time and high workloads, further delays the process of gaining actionable insights. For reporting and compliance purposes, healthcare organizations still often rely on manual, time-consuming processes to track performance, audits, and regulatory requirements. Some are still even using fax machines. These methods are not only inefficient, but also increase the risk of errors and inconsistencies in the reporting. Lastly, the constant need to adapt to changing regulatory requirements and evolving reporting standards makes it even more difficult to keep up with the demands for accurate, timely data and insights. In short, healthcare organizations face a critical data gap where fragmented systems, volume of data, and lack of self-service tools and manual processes hinder the ability to effectively translate complex data into clear, actionable insights that drive better decision-making and outcomes. So what if one of your team members could just ask a question and get an answer? Today, I am very excited to announce and to introduce to all of you SAS Viya Copilot for clinical data discovery. Over the next few days, you're going to hear an awful lot about the platform feature, SAS Viya Copilot, which is the framework we use within our feature. SAS Viya Copilot for clinical data discovery transforms data access within the SAS Health ecosystem by using large language models, or LLMs, to translate text SQL queries, and then SAS Health executes them directly against our common data model. This allows users who do not have a strong technical background, whether it's limited SQL knowledge, who previously had to rely on technical resources, access to better data quicker, and help drive analytics and improve outcomes while improving time to value. Through Copilot, we can now easily create patient registries, conduct basic data queries, support more informed data-driven decisions, most of which I will show you today throughout the demos. So for Copilot, we are really trying to make data more accessible one question at a time. So for this demo, I'm going to concentrate on what we call ad hoc queries, or just questions a user can ask to get answers about the data that they have already ingested into our common data model using our ETL process. So for example, identifying an observation that doesn't have a code. So for this first demo, you're going to see that SAS Health, or SAS Copilot, can be accessed in SAS Health through the Enrich menu. At first, you're going to be asked to acknowledge that the queries may include sensitive information. I can bypass this in my demo environment, but to the right, you're going to see a historical panel. This is going to show my conversations or topics segmented by time period. There's also a search bar, which allows you to search within the title or within the content of this topic for a particular word. For example, asthma. I'm going to search for asthma, and I'm going to find one conversation. I'm going to double click on it, and I can re-access this conversation or topic. Now that I'm done with that, I'm going to start a new topic. As you can see at the bottom, there are a bunch of predefined prompts which an organization can make themselves. I'm going to click on identifying all patients ages 40 and above with no prior heart disease diagnosed but with 2 or more risk factors, such as high blood pressure and diabetes. That ran faster than I could actually say that sentence. When I hit the SQL button, you can see that we actually have a copy of the SQL that was generated through Copilot. I can also copy this code if I need to bring it into a different part of my into a different area. I'm going to go and hit example prompts, because not only do we have more prompts available, but I can create my own if I need to. So I'm going to search for my duplicate prompt. I'm going to double click on it, and I'm going to run it. And when it runs, it's going to be looking for duplicate patients based off name and birth date. And it's going to find 3. Now, these prompts that we've stored are really important for standardization within our organizations to help drive efficiencies. But now that we've gone through our standard prompts, we're going to start to look at more what are true ad hoc queries. So for the first one, I'm going to do a simple count. And I'm going to ask it to give me the count of patients within my common data model who are under the age of 55 and have been diagnosed with sepsis. And once I slowly type this in, it's going to go out and it's going to find from the common data model that I have 216 patients with sepsis. For the next one, I'm going to do a quality prompt. And so I'm going to ask it how many patients within our common data model do not have a home phone number. And I could use this for email address, I can use it for address, I can use it for whatever, and that's going to find 3. Next, I'm going to go a little bit bigger. And I'm going to ask it to tell me how many patients who have died in the last 6 months, along with their name, their birth date, and their deceased date. And I'm gonna do this because I think that potentially my capacity and my utilization within my practice could be impacted, and this could be one of those driving results. So it's gonna go out, and it's gonna query the data, and it's gonna produce a pretty big list of patients who have died in the past 6 months. Lastly, I've also noticed within my practice that female patients around the age of 40 haven't been getting their mammograms. And as we all know, that is a gap in care. So I'm going to ask Copilot to give me a list of patients between the ages of 40 and 43 who have not had a mammogram within the past 15 months. This is going to help me figure out if my instincts are correct and that patients are not getting their mammograms, and if I maybe want to start some sort of email blast or education or something to do outreach to them, telling them about the importance of getting their first mammograms. After I find that I do have this list of patients, I'm going to ask them for their home phone number, and I'm going to ask for their date of their last visit, because maybe they're also not going to have their last visit as well. And as you can see, it easily added those data points to the query, and I can see it in front of me, and now off-site, I can go figure out what I want to do. As you can see through all of these, I could very easily just ask a natural question, and it would turn back to SQL pretty quickly to get those ad hoc results back to me. So I said before that you're going to hear an awful lot about SAS via Copilot over the next few days, and our feature leverages that framework. So I'm going to take a moment to highlight the architecture for each. So as you just saw within SAS Health, our user has submitted a natural language prompt within our user interface, which then at that point, our SAS Health GenAI API has received their prompt and has forwarded it to the Platform Gateway API. The Gateway API then uses a Python-based logic to invoke the GPT-4o model with input prompt. The GPT-4o model will process that input and return the SQL query in line with our SAS CDM. The SQL is then routed back to the GenAI API, which executes on the customer's common data model, and the query result is returned within the UI to our customer. Now from the platform side, the GenAI platform AI is integrated with Via 4. It is a centralized framework which calls LLM stored in the SAS Azure tenant through a secure gateway. It is trustworthy and secure by design and keeps the human in the loop. And the customer data will not be stored within the SAS.com platform itself. So we've talked about a little bit about what the feature does. We've talked about how it works. Now let's talk about who it's for. So this feature can really be used by anyone, but we have intended for it to where we've targeted people who are a little less technically advanced, so a little less technical than a developer, let's say. And we're targeting it to people like clinical quality analysts, healthcare analysts, population health managers, data scientists, and business operation admins. Our goal is to provide a tool that simplifies complex data analysis, provides actionable insights, streamlined processes, and improves decision-making by offering an intuitive interface that doesn't require advanced technical skills. This allows our healthcare professionals to focus more on patient care, regulatory compliance, and strategic decision-making while improving productivity and outcomes. So let's take a moment to talk about the benefits of the feature. It is designed to democratize data access across healthcare organizations by enabling clinical, operational, and administrative staff to make data-driven decisions without needing SQL expertise. It empowers users to detect trends and abnormalities early, whether they relate to patient outcomes, staffing inefficiencies, or financial performance, helping address issues proactively before they escalate. Rather than navigating complex dashboards, users receive simplified, actionable summaries that translates raw data into clear insights. This not only streamlines reporting, but also makes insights more accessible to frontline healthcare workers and decision makers alike. It brings together data from across clinical operations and financial systems, offering a unified view that supports holistic decision making. By reducing the dependencies on data and IT teams for everyday questions, it also frees up those valuable resources and accelerates response times from them. Most importantly, Copilot fosters a culture of trust and self-sufficiency, allowing healthcare professionals to just explore data securely and confidently, giving faster results, more informed decision-making, and that ultimately enhances patient care, operational efficiency, and financial sustainability, which is what everybody wants. So for the second demo, we're going to show how easy it is to create a diabetes patient registry. Normally, now the large volume of fragmented data that I would have had to rely on technical resources. But now with Copilot, I could easily list these patients myself so that my team can then provide outreach and education, enroll patients in care plans, or even reduce hospital admissions. So for the start of the second video, we need to create a list of patients. I think I also need to hit the start button. So, one moment please. So, we need to create a list of patients to start, right? And so we need to make sure that we do this in a smart way. And I want to look at not only diabetes patients, but diabetes patients that have multiple comorbidities. So I'm going to look at for diabetes patients with hypertension and obesity. And I'm going to ask at the same time for Copilot to give me these patients with their patient ID, their first name, and their last name. Once it returns the query results, we're going to see that it does give me a list of patients with exactly the data points that I need. Next, I need demographic information. So think about every time you go to the doctor's office, they ask you for patient verification, right? So I want that same information. I want the birth date, I want the birth sex, I want the age, the phone number, and I want the deceased date in case I need to filter out these people later on for my actions. As you can see, I'm going to add this, and it's going to put that demographic information right on the query. Next, I want to know when the last time the patient had an encounter. So when was the last time they had a hospital visit? When was the last time they went to a doctor's office? So I'm going to ask it to include the most recent encounter and the date of that encounter. And I'm going to ask for the ID as well, because in the back of my mind, I'm thinking that that's going to be important. It's going to go out, and it's now going to add encounter data to this query. Next, now that I know when the most recent encounter is, I want to know who that patient saw. So what practitioner did that patient see during that encounter? And I also want to know what type of encounter it is, because it's pretty important whether that's just a normal everyday appointment or if it was an ED visit. So I'm going to ask for those two data points as well. Once we've done that, we really want to start to look at other areas. We want to start to look at our observations. We all know that A1C is pretty important when talking about diabetes patients. So I'm going to ask for the most recent A1C value and the date of which that was taken and add that to the query, because I know that that's going to help me later on with my patient registry. Once it adds this value, you're going to see next. Now that I have all these data points, I want to learn a little bit more information about the encounter. So I want to know where this encounter happened and what organization it happened within, right? Because this could be important later on. So I'm going to ask for the city and state of that encounter as well as the organization name. It's going to go out and it's going to add these data points as well to the query. So as you can see, I have quite a bit of data points at this point within it. I can still expand my SQL query, and it's pretty long for what we've created. Remember, I can still copy this as well if I need to use it elsewhere. Now, instead of ending it at this point, we're going to create a data view. So I'm going to come in, I'm going to hit the data view button, and I'm going to name it something very simple like patient registry. And then I'm going to save this data view so that I can access it other places within SAS, within VIA. So once I hit save and my data view has been created, within SAS Health, I can navigate to manage data, which is Data Explorer. Once I open up Data Explorer, I can find the CAS lib in which I saved this data view in. I can search for it. Once I find it, I can very easily put it in memory. And once I do that, we can see that within that registry, I have almost 4,000 patients. And from here, I can go right into VA, and I can start to create my report with this data that I found in Copilot. So if I hit within VA, the new report button, I can now go in. I can find that data view I just created in Copilot, and I can add it, and I am set to go working with this data directly in VA. This video is 4 minutes long. Within those 4 minutes, I combined 7 different tables across the enterprise and found a list of almost 4,000 patients. That's pretty impressive for someone that is not a nurse and that really doesn't have a ton of technical skills, right? And so let's talk about what we can do with this data after the fact. So after I've put it into VA, I can actually work with VA, and I created this very, very simple report, right? So in the first page, I can see just basic metrics, whether it's the segmentation by birth or by age. But here's my patient list that we were striving for. I have 3.8 thousand, little under 4,000 patients, right? And I have 2 filters across the top, one for A1C and one for an encounter type. I'm gonna come in and I'm gonna first start to look at patients that have an A1C greater than 7.5. And right away, I'm gonna get this number down from a little over to 34. From here, I'm gonna look at patients that have had their most recent encounter as an ED visit first, because they're who I wanna target. I'm now down to 2, Brad and Napoleon. I wanna know more about Brad, so within SAS Health, I'm gonna go and look at our out-of-the-box dashboards for the patient insight dashboard, and I'm gonna look up Brad so I can find out more information about him that's in our common data model and really start to get that 360-degree view of the patient. So when I come in and I can type Brad, I'm gonna find him. You can see right across the top, I have my demographic information, and in the middle, I have my encounter information, as well as now I can see that there have been some spikes in Brad's work. So maybe there is a reason that we need to outreach to him. I also have my conditions, my diagnostic reports, my medications, my procedures, and my observations. Not only can we see this data in this report, but we can also go to the predict model, to the predict area, and I can go into build models, where I'm navigated again within SAS Health to Model Studio, and I have this model that my coworker made called diabetes and hypertension, and now I can see this data within this model as well. So I have the data, I have the pipelines, and I have this insights. So not only did I find this, we ingested this data into the CDM, I then used Copilot to figure out a targeted population. I then looked at analytics from the power of VIA through VA and through Model Studio, and I could keep going. SAS VIA Copilot for Clinical Discovery is a SAS VIA Copilot capability and will be available as part of SAS Health at no charge, starting hopefully in Q3. Also, SAS VIA Copilot is compatible with VIA 4 deployments. It is for SAS hosted managed services, customer managed cloud, and customer on-prem deployment connected to the internet. And that's it. Thank you. I think we are at time, but we will be at the HLS booth and throughout the week if anybody has questions.